Imagine a machine that does not merely answer your questions, but actively pursues goals on your behalf. This is not a distant vision from science fiction. It is the reality of agentic artificial intelligence, a paradigm shift that is rapidly unfolding today. These systems, often called autonomous agents, possess the capacity to formulate plans, make independent choices, and execute tasks within their environment with minimal human intervention. They represent a fundamental leap from passive analytical tools to active participants in our digital and physical worlds. The proliferation of this technology is poised to redefine the very fabric of our daily lives, our industries, and our relationship with computation itself, ushering in an era of unprecedented automation and capability. So, what precisely is agentic AI? At its core, an agentic AI is a computational system designed to perceive its environment, make decisions, and take actions to achieve specific goals. The term agent is crucial here. It signifies a capacity for autonomous action, an ability to effect change in a given domain. Unlike a simple predictive model, an agent is not a passive oracle that offers a single output. Instead, it is an active participant that engages in a continuous loop of sensing, thinking, and acting. This domain of action could be purely digital, such as navigating websites, manipulating data, or it could be physical, involving the control of robotic limbs, control of vehicles in the real world. The primary distinction between agentic AI and what we might call conventional AI lies in this capacity for sustained, goal-directed action. A conventional AI, such as an image recognition system, performs a discrete task and then stops. It might correctly identify a photograph as containing a cat, but its function ends with that label. One of the most prominent is the autonomous vehicle, camera's LiDAR radar. It processes this torrent of data to build a model of the world around it, identifying other vehicles, pedestrians, road signs based on its goal of reaching a destination safely and efficiently. It makes thousands of micro decisions every second. Steering, acceleration, braking, its actions directly affect the physical world, and the stakes are incredibly high, demanding an extremely high level of reliability. In the digital realm, we are seeing the emergence of sophisticated virtual assistants capable of executing complex, multi-step tasks across different applications. For example, plan a weekend trip to San Francisco next month. Browse for flights, compare prices across airlines, search for hotels by price and location check reviews, present a curated itinerary for approval. It acts as a personal digital intern, logging into websites, filling out forms, navigating user interfaces. Another compelling example comes from the world of scientific discovery. To truly understand agentic AI, we must look under the hood at the fundamental operational cycle that governs its behavior. This process can be broken down into a continuous repeating loop of distinct phases. The first phase is sensing, or perception. An agent must first gather information about its environment and its own internal state. For a physical robot, this involves processing data from cameras, microphones, tactile sensors. For a software agent operating on the internet, this means parsing the HTML of a web page, reading data from an API, or analyzing the contents of a file. This raw data is the agent's only window into the world it inhabits. The second phase is thinking, which encompasses modeling, reasoning, and planning. After sensing the world, the agent must make sense of the information it has gathered. It often builds an internal world model, a simplified representation of the current situation. Using this model, the agent reasons about its circumstances. It considers its overarching goal, which may have been provided by a human user. At the heart of many contemporary agents are large language models. These powerful models, trained on vast amounts of text, trained on vast amounts of code, serve as the cognitive engine for the agent. They provide a sophisticated capacity for natural language understanding, allowing the agent to interpret complex human instructions. More importantly, LLMs exhibit nascent reasoning abilities. LLMs exhibit nascent planning abilities, enabling them to decompose a high-level goal into a logical sequence of steps, effectively creating a blueprint for action. To execute these plans, agents rely on a framework for tool use. An LLM on its own is a disembodied brain. It can think and write, but it cannot act upon the world. The agent architecture connects this reasoning engine to a suite of tools. Simple calculator calendar, API, web browser controller, code interpreter. This modular approach is incredibly powerful, allows a general-purpose reasoning model to leverage specialized functions. The benefits of successfully developing and deploying agentic AI are immense and far-reaching. The most immediate advantage is a dramatic increase in productivity and efficiency through automation. Agents can take over complex tasks, time-consuming tasks, repetitive tasks. They can manage supply chains, process invoices, conduct detailed market research. This frees up human workers to focus on creative work, strategic work, interpersonal work. That could lead to greater job satisfaction and economic growth. For individuals, personal agents could manage schedules, handle correspondence, automate digital errands, giving back time. Agents could democratize expertise, making complex skills accessible to non-experts. They can extend human capabilities and improve quality of life. In science and engineering, agents can accelerate discovery by running complex simulations and experiments around the clock. In healthcare, agents could provide personalized support for chronic patients, but the promise is mirrored by serious risks that need proactive mitigation. A primary concern is misaligned objectives. Agents pursue programmed goals with literal single-minded determination. This shows the need for precise, value-aligned goal specification, a problem not yet solved. We must proceed with caution, building containment, oversight, and guarantees that humans can always intervene and retain ultimate control.